Welcome guys to another video. This video is on lever, which is a simple machine. Then we'll understand the types of classes and their mechanical advantage. So let's begin. Levers, as we know, are simple machines. But what are simple machines? Simple machines are the simplest mechanical devices that we use in our daily life to make work easy. So for example, scissor, punching machine, knife are the examples of simple machines. We also have compound machines. And what are compound machines? Compound machines are a collection of simple machines working together, and they do more complex work than individual simple machines. So when we have a combination of more than one simple machine, two, three simple machines coming together to make a complex work easy, such type of machines are called as compound machines. Compound machines perform more work and therefore offer a greater advantage than simple machines alone. Types of simple machines. Let's understand different types of simple machines. We have 6 different types of simple machines. First, lever. What is a lever? Lever is a straight rod like this that balances itself at a point. It is used to lift heavy weights. For example, where do we see lever? The seesaw is an example of lever. So what is a lever? It is a straight rod which is balanced on a point, and it is used to lift heavy objects or heavy weights. Second type of simple machine is wheel and axle, where a wheel is attached to the rod so that they rotate together. It makes easy to move things by reducing friction. We have a wheel. Through this wheel at the center is the axle. Both of these work simultaneously. So if the wheel rotates, along with it the axle will also rotate. So it makes the work easy by reducing the friction. And where do we find this? A door and door knob is example of wheel and axle. So when you rotate this wheel, the knob of the knob, then the axle which is attached to it also rotates, and it helps us to lock and unlock the door. Third example is an inclined plane or a ramp. What is a ramp? It is a flat surface or a plank where one end is at a higher height and the other end is at a lower height. So it reduces the amount of force required to move an object. And best example is the slide that we see in the garden. So up to now we have seen 3 types of simple machine. First one was the lever. Second one was the wheel and axle. And this third one is a ramp or an inclined plane. Now next one, fourth simple machine is a wedge. It is an object with 0 thickness at one end and gradually increasing thickness towards the other end. So in this example, if we see, this is a wedge. So having 0 thickness at one end and gradually the thickness increases. So this becomes the wedge. It is a triangular shape and are used to separate or hold an object together. So example of wedge is knife, axe. Then zip is also an example. Okay, so zip is a wedge shape where it is used to hold these 2 pieces together. Fifth is a pulley. What is a pulley? Pulley is a grooved wheel with rope over it. Makes lifting of heavy objects easy by changing the direction of an applied force. So a grooved wheel through which a cable or a rope is made to pass. So here the work is made easy by changing the direction of the applied force. Where do we find pulley? For the pole, for using flag hoisting, we have this post where pulley is used. And sixth, the last simple machine is a screw. What is a screw? It is an inclined plane wrapped around a pole. So it is an inclined plane which is wrapped around a pole. It converts rotational motion to a linear motion. So as you rotate this, the screw will either move up or down, and it is used to lift things or to hold things together. So example is a bottle where its neck is threaded. So this will hold the things together. The lid and the neck both has the threading. So it helps to make it as a one object, right? So we have understood what are simple machines. There are 6 types of simple machines, and now we come to compound machines. As we know, compound machines are collection of simple machines working together. They do more complex work than individual simple machines, and they offer greater advantage than simple machines alone. Hence, they become more beneficial. For example, compound machine, a cycle. Now, to have a cycle as a whole machine or a whole assembly, there are small parts which work in combination as a simple machine, and thus becomes the whole thing as a compound machine. For example, here the pedals, the wheels form cooperating lever and wheel and axle system. The brakes are the levers, and various parts are held together with multiple screws. So here we are making use of simple machine, that is lever, wheel and axle and screws. Now let's understand more in detail about the lever. What do we mean by lever? As we have already seen, lever, it is a simple machine consisting of a beam or a rigid rod pivoted at a fixed hinge or fulcrum. Pivoted means balanced at a fixed point called as fulcrum. It is a rigid body capable of rotating on a point on itself. Now this is what is a lever. So the lever is made up of 3 parts. We have an effort. What do we mean by effort? Effort is a point where force is applied. So a point where force is applied, that becomes our effort. Then we have a load or resistance. It is a point where the applied force acts. Now you have applied force here. So whatever is the result of that force, that is where we say it is a load, a point where the applied force acts. And then we have a fulcrum. It is a fulcrum means a point, a fixed point which acts as a support for this whole assembly. So once again, what is effort? Effort is a point where force is applied. Load or resistance, some books say resistance also, is a point where the applied force acts, and fulcrum is a fixed support. Now, basis of this location of the effort, the load and the fulcrum, the lever is divided into 3 classes. But before that, let's understand what is mechanical advantage. Shortly, it is abbreviated as MA. It is the measurement of the extent to which a simple machine amplifies or multiplies the applied force. So whatever force is applied as the input, so at the output, what resultant force we get, so we come to know how much input force is being converted into an output force. So mechanical advantage is the measurement of the extent to which the simple machine amplifies the applied force, or we can say it is the force amplification achieved by using a tool, a mechanical device or machine system. Now this is the case. Here we need to understand 2 terms, the effort arm and the load arm. So what is an effort arm? Effort arm is the distance from the effort to the fulcrum. So this distance becomes the effort arm, and the distance from the load to the fulcrum is the load arm. So these 2 terms you should understand, effort arm and load arm. Effort arm is the distance of the effort and the fulcrum, and load arm is the distance of the load to the fulcrum. And what is mechanical advantage? It is ratio of the length of the effort arm to the length of the load arm. Now mechanical advantage also, if you know the force, input force and output force, you can say mechanical advantage is ratio of output force to input force. Now as we understood that based on the position of the effort, load and fulcrum, lever has got 3 classes. So first class is what? Which type of, what is the arrangement for the first class? For the first class, fulcrum is in between the load and the effort. So here is the fulcrum and here is the load and here is the effort. So now example of this is a hammer or a scissor. So hammer, you can see as the picture shows, this is where we apply the effort. Effort is done here. This nail we want to remove, so this nail becomes the load and this junction is the fulcrum. Similarly for scissor, this is where we apply the effort. This is the place where we keep the load and this is the fulcrum. Fulcrum is a fixed point. So now what we are, the first class lever, mechanical advantage, first class lever, remember fulcrum is situated between load and effort. So it is the ratio of length of effort arm to the length of load arm, right? So now depending upon this distance, our mechanical advantage for first class lever will vary. So if the fulcrum is closer to the load, now suppose fulcrum is closer here, so obviously the length of the effort arm increases, so mechanical advantage has to be greater. However, if the fulcrum is at the center, exactly at the middle of effort and load, then the ratio becomes 1. And if the fulcrum is to the side of the effort, then the length of the load arm increases, and in that case mechanical advantage will be less than 1. So for first class lever, mechanical advantage will take the value of 1, less than 1, or is equal to 1. And what is first class lever? It is a lever where fulcrum is situated between the load and the effort. Now second class lever. Second class lever, load is situated between fulcrum and effort. So you can remember second word ends with D. Load word ends with D. So load is situated between the fulcrum and the effort. So we have the load which is between the fixed point and the effort. So example of this is a nutcracker. So this is a fixed point. Here you apply effort and here is the load. Also a wheelbarrow. This is a fixed point. Here is the effort and here is the load. So in this case, as we know, mechanical advantage is the ratio of length of effort arm to length of load arm, right? Now because here load is in between the effort and load, so obviously this distance is less as compared to this distance, right? So the mechanical advantage here is always greater than 1. Hence it is also called as force multiplier lever, right? Now is the third class lever, that is effort is situated between the fulcrum and the load. Effort, you should remember the word third, R is here, effort, R is here, right? So effort is situated between the fulcrum and the load. Once again to revise with, for first class lever, fulcrum is between the load and effort. For second class lever, it ends with D. So it is the load which is between the fulcrum and the effort. And third class lever, R is there. So it is effort which is between the load and the fulcrum. So what are the examples of third class lever? A broom and a pair of tweezers, right? Broom, so here in the picture you can see, here is the effort, you hold it here, this becomes the center point or a fixed point, and this becomes the load. Fulcrum, this becomes a fixed point, this is effort, you have to hold it here, and here will be the load. Now here mechanical advantage, once again it is ratio of length of effort arm to length of load arm, right? So now here effort arm is smaller whereas load arm is bigger, so obviously this mechanical advantage will be always smaller than 1, and it is also called as speed multiplier lever. So hope the concept of lever, types of lever and mechanical advantage with respect to lever is clear. Do like, share and subscribe the channel for more such videos. Thank you.